Speed Maths 11. Train-based problems. Basic concepts of train-based problems. The speed of an object describes the distance traveled divided by the time taken to cover the distance. Thus, distance is the product of speed with time. Pole, tree, boy, and girl are zero length objects. Platforms, bridges, and tunnels are examples of long objects. Unit converters. To convert kilometers per hour into meters per second, simply multiply 5 by 18. The answer we get is the speed in meters per second. To convert meters per second into kilometers per hour, simply multiply by 18/5. The answer we get is the speed in kilometers per hour. Model 1. Speed of the train. Example 1. A man sees a train passing over a bridge of length 1 kilometer. The length of the train is half of the length of the bridge. If the train passes the bridge in 2 minutes, then find the speed of the train. According to the given conditions, the total distance that the train must cover to cross the bridge is 1 plus half a kilometer, or 1.5 kilometers. Substitute 1.5 kilometers and 2 minutes into the speed, distance and time formula, then multiply by 60 to convert minutes to hours. As a result, the train's speed is 45 kilometers per hour. Model 2. Platform problems. Example 1. A 300 meters long train crosses a platform in 54 seconds while it crosses a signal pole in 18 seconds. What is the length of the platform? According to the given data, it takes 54 seconds to travel the length of a signal pole and a platform. If the train passes through a signal pole in 18 seconds, then it will cross the platform in 36 seconds. A train 300 meters long crosses a signal pole in 18 seconds and the platform in 36 seconds. Based on this information, we will frame two equations. 18 seconds equals 300 meters. The length of platform X is then 36 seconds. By solving X, we obtain the platform's length of 600 meters. A train of length 250 meters passes a 350 meter length platform in 50 seconds. What time will this train to take pass a platform of 230 meter length? According to the problem, the length of the train is 250 meters. The length of the platform is 350 meters. The total length is 600 meters. The train takes 50 seconds to pass the 350 meter platform length, including the 250 meter length of the train. The time required passes the 230 meter platform length, including the 250 meter length of the train. Based on this information, we will frame two equations. 600 meters equals 50 seconds. 480 meters is then x seconds. By solving x, we obtain 40 seconds to pass a platform. A train crosses a bridge of length 150 meters in 15 seconds and a man standing on it in 9 seconds. What time will this train take to pass a platform of 450 meters in length? According to the given data, it takes 15 seconds to travel the man and a bridge. If the train crosses a man in 9 seconds, then it will cross the bridge in 6 seconds. If a train crosses a 150 meters bridge in 6 seconds, then it will take 18 seconds to cross the 450 meter platform. The answer options are not available in 18 seconds. So, we assume that the man is standing on the platform. The time taken to pass the platform is 18 seconds plus 9 seconds, which equals 27 seconds. Model 3. Relative speed. Example 1. 180 meters long train crosses train B of 120 m in length, which is running in the opposite direction in 5 and 5/11 seconds. If the speed of train B is 20% more than that of train A, then find the time taken by both trains to cross each other. When are they running in the same direction? Let's say train A travels at 100 kilometers per hour, while train B travels at 120 kilometers per hour. The ratio of the speeds of trains A and B is 100 to 120, or 5 to 6. When both trains are traveling in opposing directions, the relative speed is 6 plus 5 equals 11 kilometers per hour. When both trains are traveling in the same direction, the relative speed is 6 minus 5 equals 1 kilometer per hour. The opposite and same direction speed ratio is 11 to 1. However, speed is inversely proportional to time. the time ratio becomes 1:11. The 1 represents 60 by 11 seconds. Then we need to compute the time taken by both trains to cross each other. When are they running in the same direction? Then we need to compute the time taken by both trains to cross each other. When are they running in the same direction? As a result, 11 into 60 by 11 equals 60 seconds. Model 4. Train accident. Problems. Example 1. A train after traveling for 50 kilometers met with an accident and then proceeds at 3/4 of its former speed and arrives at its destination 35 minutes late. Had the accident occurred 24 kilometers farther, it would have reached the destination only 25 minutes late. What is the speed of the train? Let A be the starting point and B be the ending point. C and D are the locations of accidents. According to the problem, the ratio of the train's speed after an accident to its original speed is 3 to 4. However, speed is inversely proportional to time. The time taken by the train after the accident to the usual time is then 4 to 3. In this case, the time difference is 1. The difference between 35 minutes and 25 minutes is the actual time required to travel the distance, which is 10 minutes. As a result, 1 denotes 10 minutes. We must first calculate the usual time of 3, which represents 30 minutes. Substitute 24 kilometers and 30 minutes into the speed distance and time formula. The train's original speed was 48 kilometers per hour. Example 2. A train met with an accident 3 hours after starting, which detains it for 1 hour, after which it proceeds at 75% of its original speed. It arrives at the destination 4 hours late. Had the accident taken place 150 kilometers further along the railway line, the train would have arrived only 2 hours late. Find the original speed of the train. Let A be the starting point and B be the ending point. C and D are the locations of accidents. According to the problem, the ratio of the train's speed after an accident to its original speed is 3 to 4. However, speed is inversely proportional to time. The time taken by the train after the accident to the usual time is then 4 to 3. In this case, the time difference is 1. The difference between 4 and 2 hours is the actual time required to travel the distance, which is 2 hours. As a result, 1 denotes